Welcome back, boys. This is the next lesson in Chapter 8. So far you have learned different characteristics of what it is to be a quadratic function. Okay, so obviously you've been graphing parabolas. Well, if you've been graphing other things, well, then you've been doing it wrong, obviously. So I'm going to take it a step farther, and we're going to do some other, transformations of these parabolas. So you learned how parabolas can shrink, which means get wider, or they can stretch, which means they get skinnier. So that's something you should remember. But today, we're going to be moving up and down, okay? So if you look at this, you see three different parabolas. The blue one that you see is the parent function, okay? And the parent function, I mean, is your f of x equals x squared. And of course, your a is 1, okay? And your vertex is always going to be 0, 0, okay? Now, what's different is if you look at the green one, see how the green one moved up and its vertex is at some number, but it doesn't matter what number it is, it's up. That is when you have a plus c, so plus some number, it's going to shift your parabola up, and the shift is called a vertical translation. Now, when c is a negative number, so if you look at here, when c is negative or obviously less than 0, then you're shifting down. So notice your parabola vertex went down. So what holds true is, if I highlight this, your axis of symmetry is still x equals 0. That has not changed. But what's changed is the vertex. Okay, so the vertex right here is what's different. So it's either going to go up or it's going to go down. So here in layman's terms is what it means. So if your c is a positive number greater than 0, it's a vertical translation or shift up c units. Okay, so if c was 3, then it would be a shift vertically up 3 units. If c was negative, so if it was a negative number, it would be a vertical translation down that many units. Okay, so positive is up, negative is down. Pretty self-explanatory. So looking at our problem, this is going to be our function, so g of x. So it's x squared plus 3, and we're still going to compare it to our parent function. So first thing we need to do is make our table of values. And I kind of changed my table like I did from the other ones before. But these numbers right here are always going to be the same. And those ones I get, in case you're super confused where I got those, is you take your x's, which I'm always going to tell you, and you're plugging them in, and you get 4, 1, 0, 1, 4. Those are going to be the same. So you should write those on every single homework assignment. Okay, now what's different is I'm taking these ones and I'm plugging them into g of x now. So they're going to change slightly. So if I do -2, I do -2 squared plus 3. I get 4 plus 3 is 7. Do -1. And then I get what? 1 plus 3 is 4. 0 we can do in our head. You would obviously get 3. Now, by definition of symmetry, this would be a 4, and that would be a 7. Now, you might even notice not like a pattern, but like a shortcut. If you look at 4, 7, 1 to 4, 0 to 3. A lot of these values, actually all of them, jumped up 3 units. So that might be a key thing you might want to think about. So now I'm going to take my blue dots and I'm going to graph it. And I'm going to draw my line. So here's my parabola. But notice it's like shifted up. It's kind of floating in the air. And that vertex is not at 0, 0 anymore. So now I'm going to compare this to my parent function. So there's my table of values. Notice the red values didn't change and the blue ones were the ones we just found. Now, here's my parent function. This is what you should always be graphing first. Okay. And now I'm going to put my blue one on that you just saw. And I will connect these dots. So now is where you need to compare them. So let's fill in my axis of symmetry. So axis of symmetry is still x equals 0. But the only thing that moved was my vertex. So my vertex went from 0, 0 to 0, 3. So here's what I would need you to write. Both graphs open up, which is standard, and have the same axis of symmetry, which was x equals 0. But the vertex of g of x is 0, 3 because it is a vertical translation of 3 units up of the graph of f of x. So the first sentence is what you're always going to write down because that's always going to be the same. But the second sentence of your vertex moving is what's different. Okay, so this one was just a vertical translation of 3 units up from 0, 0. And if you go back to looking at your table, all you had to do was add 3 to your parent function. So that's the shortcut, is you don't have to plug them in. If it's a plus 3, then these all shifted up 3. Okay, now of course you can still show me the work. So now let's do one where it's a minus. So if you look at this one is h of x, and it's x squared minus 2, and we're still going to compare it to our parent function. So table of values, again, they're my standard red numbers, but now you're going to take your x's and you need to plug them into now your h function. So if you do -2, be -2 squared minus 2. PEMDAS, you get what? 4 minus 2, you get 2. I'll do it for -1. Whoops. So -1 squared minus 2. So what is that? 1 minus 2, which is -1. 0 is easy. It's not going to be 0. It's going to be -2 because it's going to be 0 squared minus 2. And then obviously, by definition of symmetry, there are my points. Plot my points. So there they are. Let me connect. There's my graph. And I already drew my curve. So notice, it went down. So the vertex is not 0, 0 anymore. Oh. So there's my table of values. Plot your parent function first. And if I do the blue one that you just did, there's the blue one. So look, it went down. So let's do some compare and contrast. So x equals 0 is still my axis of symmetry. But look at your vertex. Your vertex is now 0, -2, where before it was 0, 0. So here are the words you need to write. Both graphs open up and they have the same axis of symmetry, x equals 0. But now the vertex of h of x is 0, -2 because it's a vertical translation 2 units down of the graph f of x. Okay? And you boys, trust me, you will get the hang of this, okay? We're going to do it in baby steps, and then next week we're going to put it all together. Let's do one more. All right, so this one is s of x. So it's x squared minus 6, and again, we're going to compare it to our parent function. Table of values. Now let's actually do the shortcut here. We don't really necessarily have to plug in all of these. So you're going to take all of your red values, and all you have to do is subtract 6. Because a lot of you might even realize that this parabola is going to be 6 units down from your vertex. So this would be -2, -5, -6, -5, and -2. Now, if you did not understand anything I just did there, then you certainly can plug them in. So that's the shortcut, is you just take this and you subtract it from the parent function. So those are the points. Notice how far down it is. And now drew my curve. Now let's compare this to our parent function. Those are the same numbers we just had. There's my parent function. Here, let's write vertex 0, 0. There's my blue one. Notice how far down it is. And your vertex looks like it's 0, -6. But your axis of symmetry is still the same. So axis of sim is still x equals 0. So probably can already guess it. This is what I'm going to write. Both graphs open up and have the same axis of symmetry, x equals 0. The vertex of s of x is 0, -6, because it is a vertical translation of, typo, 6 units down of the graph f of x. Okay, so all of these shifts are now vertically. They're moving up or you're moving down. Okay, so hopefully you know exactly what I expect. I'm going to put a sample problem on Moodle so you can see what I want you to write. And it's another worksheet. So I will see you guys next time. Bye, boys.